All right, class, how's it going? We're going to be going over your super quick, special cases in chapter 3. This was your homework from last night, so if you need help looking at the answers, or maybe you're having some questions about a couple of them, this video is going to explain every single problem, okay? So here we go. We're going to go through these. All right, so we're going to start off with this first one right here. And this first one I put up on the board already, so you kind of saw with the example in class, okay? But I'm going to explain it just one more time. Okay, so assuming, look, you have a problem here to begin with, and I'm going to give you some of these in your test, but you have a problem here that you need to isolate first. Remember, you got to put all the x's on one side, all the numbers on the other side. So here's what I did for this one first. Basically, all I'm going to do is, let's move the x's together. Let's put this x with this x. So we're going to do the inverse, right? We're going to do maybe minus x, minus x. I'm going to draw my line down the inequality sign. Now, this is going to give me 0, right? Nothing's left here, and nothing's left here. So really, I just have a 5 is greater than or equal to a 3. Now, remember, whenever you come across a problem like this, that just you end up with two numbers maybe on both sides and no variables, and it's just this is all you see, well, then you got to ask yourself, does it make sense? And this is where you have to read it out loud to yourself. Is 5 greater than or equal to a 3? If that's true, then guess what you have? All real numbers. Because this is saying, because this statement is true, it means that any number I plug in over here where the x is, here or here, it's always going to make this thing true. For example, if I was to put, I don't know, let's just say 20s where the x's are. 20 and a 20, right? If I was to put 20s there, that's a horrible color, huh? Let me use red. A 20 there and a 20 there. Okay, well, that would give me 23 here, and that would give me 25 here. This side's always going to be bigger, regardless of whatever I put in here. So that's why this is all real numbers. Okay, moving on. Bring my hand down. Let's take a look at this problem. Okay, this problem says, let's see, first thing I did here, I'm going to walk you through the steps. You share 2 times x, 2 times 3, I get 2x plus 6. And this one, there's nothing to share, done. Now I'm going to move all the x's to one side, right? So I'm going to maybe move all these x's over here. Okay, so I'll do that. Minus 2x, minus 2x. Here I get a 0. Here I get 0. So really I'll end up with 6 is less than 5. And so I'm reading it now. Is 6 less than 5? No, it's not. No. I can't nod, right? So I'm moving the hand. No, it's not. Yes, it is. No, no. This is not true. That means because this statement is not true, this thing's never going to have any answers. So look what I wrote over here in my bubble. If the statement is not true, there will never be any possible answers. So there's no real number, no answer, no solutions, okay? On a test, it'll say no solutions, likely. Let's move on. Okay, so look what I did here. My first job here is to isolate this thing. Remember that word I keep saying, isolate? Isolate means get it by itself. To get this by itself, I had to do minus 7, minus 7. Now I'm here. Now the next step here that I usually see students do is they'll say, Mr. Puebla, I got to do 2 problems now. I know I got to do one that's exactly the same, and then I have to do one that is almost the same, but I switch and positive, right? You're probably thinking this, and then you solve it and you get some answers, but guess what? You should have stopped already. Why do you think you should have stopped? I'll drop this in here. Why should I be using this guy right here and saying stop for a specific reason? Look what this says. Let me read this to you, because this is the part that really some of you probably are having a hard time reading. This says that this side over here is going to be greater than a negative number. Well, is there ever a time that when you use absolute value, these lines right here, that you end up with a negative number? Is it? Well, like if I have an absolute value negative 20, does that give me a negative number? No, it doesn't. No. Oh, even a 20, that doesn't give me negative. No, it's still going to be a 20. So anything I put inside that's absolute value, it's always going to be positive. And because whatever I put in here is always going to give me a positive number here, even if it's a negative 1,000, a positive 1,000, whatever, it's always going to be bigger than a negative. So because that's true, always, your answer should be all real numbers right here. All real numbers, okay? Here I wrote, if you have a negative number on the right side and greater than or equal to is facing the absolute value, you can place any real number and it will always be true. So basically it's all real numbers, right? Or infinitely many solutions. Because this is always going to be true. Let's go ahead. Keep going. Okay, moving on. I'm bringing, I don't know, we'll call it Mr. Bob. Mr. Bob will be right here. Let's finish this one now. Let's look at this. Let's see. Here I have to isolate this part. So to isolate it, I got to do +5, +5. And look what I end up with. X plus 12 absolute value is less than or equal to a negative. That means it's saying that this is never going to be bigger than this. Wait a minute, didn't I just finish telling you guys that this side's always going to be positive? And isn't a positive number always bigger than a negative? So this is not true. This whole thing isn't true. So yes, you're right, we got to use Mr. Bob here. This is not true. We got to stop here because this is never going to be a true statement. And because this is never going to be a true statement, let me see what I wrote here. Because the inequality sign is facing the negative side, this will never be true. The left side will always be more than the right side, regardless of what you put into the x. So because this will never be true, there are no solutions. Okay? You should have written something along this line in your homework part. Let's move on. Oh, I'll bring my hand down. Should I bring Bob? I'll bring Bob down. Okay, let's take a look at this one. Okay, this was the backside problem that you guys had, correct? So we're gonna go ahead and look through this one. Okay, first thing, remember you gotta isolate this. Remember, isolating means get this by itself. Remember when I had you guys highlighted with a highlighter? So let's get rid of this -3. Now remember, we're not gonna +3, +3. You don't add 3 here because this right here is like timesing with this, right? It's times. So we're gonna do instead divide by -3. Divide by -3. I'm going to do the line down the inequality sign. And I'm going to go ahead and cancel these out. So I have just this left over, right? So I'm going to have absolute value 2x plus 2. And what should I be doing with the inequality sign? I know you said turn it around or reciprocal, or not reciprocal, but just turn it around, right? Flip it. And then this is -4. Okay. Look what you got here. This is kind of like one of the special cases you just did right now. But what's so special here is it's going to be no solutions or many solutions. Well, look, this thing is saying that this side is always going to be bigger than this side. Is that true? Is this always going to be bigger than this -4? Yes. This side is always going to be bigger than a negative number. Remember, anything you put in here is always going to be positive or 0, but that's always bigger than a -4. So this is going to be all real numbers, okay? Or infinitely many solutions would work also. Let's go down to the last one. Oh, hold on. Not sure what's happening here. There we go, there we go, there we go. Last problem here, okay? Okay, you got to isolate, right? Let me highlight my absolute value. I want that by itself. And I'm going to draw a line down the inequality sign. Okay, first thing I want to do is get this by itself. So that means you got to get rid of this 4 here. Let me ask this. Does that negative belong to this 4? Nope. Nope, it doesn't. Look, I'm nodding. No, it's not. This 4. Now, is this 4 positive or is it negative? Look at the in front of it. If there's no sign here, this thing is positive. So what's the opposite of +4? -4, -4. Okay? Now these cancel, and over here I get negative 2 minus 4. Let me write it in a straight line. Negative 2 minus 4. Don't change opposite, opposite. Negative 6. Okay, so I got negative 6. Negative 6. Same sign. I don't switch it. X plus 2. What did I forget? Right there. Look, can I make it more obvious? Right there. You forgot this thing right there. This is as big as I can get it here, okay? Do not forget that negative sign. Bring it down right here. So I'm going to bring it down. Negative. Okay, so what does this mean? I have a negative right there. Well, you're not done isolating. This thing isn't by itself yet. You still have to get rid of this sign right here. How do you get rid of this little negative there? Well, this negative is like timesing this. So the other way to get rid of a negative when it's multiplying is to divide it. So I'm going to put a little imaginary 1 here. That's going to help me out. I'm going to divide by negative 1, divide by negative 1. So guess what? Some of you that probably thought, oh, wait, Mr. Ray, you got to stop. Look, it's negative over here. It's negative 6. There's no solution here, or there's many solutions. No. You got to first isolate this whole thing first. And I wasn't done isolating yet. Okay, now let's isolate this. We're going to get absolute value, x plus 2. Inequality switches. And I get a positive 6 now. So now guess what you have to do here? Now you make 2 problems. Remember doing that? 2 problems. X plus 2 less than or equal to a 6. And x plus 2 greater than or equal to negative 6. Remember, on the second one, oh, this thing is too huge, isn't it? On the second one, I told you got to change the inequality sign and change this sign to a negative, the number to a negative. Okay, 2 things got to change here. These 2 right here. Let's go ahead and solve them. Wowzers. Bless me. X is less than or equal to 4. Okay, and this over here. X is greater than or equal to negative 8. Okay, if I asked you to graph this, I wonder how many of you guys actually graphed this. I bet you no one did. Let's go ahead and graph it. I'm going to put a negative 8 over here. I'm going to put a 0 there. I'm going to put a 4 there. Okay, let's go ahead and graph the first one. The first one says x is less than or equal to a 4. That means that it's going to go this way over here, right? Going this way. So closed circle, going this way. But now let's finish up with the negative 8. Negative 8 says closed circle, and it's going the other way, right? So look, they're meeting halfway, right? That means that all the answers in here count. And that's it. What kind of problem is this? An and problem or an or problem? And, right? All right, guys. That's it. Hope you enjoyed. Fairly quick and simple. If you did not understand any of them, I hope this video helped, because now you understand all the special cases that happen in Chapter 3, and you know you'll be ready for your test, all right? Okay, that's it. Peace out. That says goodbye.